I will talk a little bit how we can use knowledge graphs and language models to organize research contributions. My name is Sören Auer. I'm director of TIB, Leibniz Information Center for Science and Technology. And we are also a participant in FAIRmat, but also involved in other NFDI initiatives like NFDI for Ing, NFDI for data science, or NFDI for energy. And yeah, to motivate a little bit what I'm talking about, I created two examples. Here's one, a figure about making data AI ready, which I created using um, an image model. And you can see that it got quite some things right. So it built here this pyramid with reusable and accessible and findable and fair, but also lots of smaller things got mixed up by generating this picture, this image. And another example, when you ask, for example, ChatGPT about the scandals, the widely publicized scandal involving Professor Auer, a few months ago, you would still get an answer with a long story about misappropriation of research funds, data manipulation, plagiarism, and so on. Nothing of which is true. Luckily, meanwhile, ChatGPT doesn't answer such questions anymore. It follows a different approach. It would do a web search and then, based on the information it finds on the web, then either summarize what it finds there or tell you that it didn't find anything. But that also shows that the language model alone is not actually able to deal with certain problems and certain questions. And I think this a little bit resembles what Daniel Kahneman described in his famous book, Thinking Fast and Slow. Generative AI can think fast, yeah, so they can discover patterns, statistical patterns in the data, but the reasoning, which now they start to also learn a little bit, but that's much harder to get this reasoning right. And one more thing, actually, and I think this actually resembles also a little bit how our human brain works. We also make a lot of mistakes. Yeah, we believe sometimes in false information. We mix up things. So I would say language models are in that regard very similar to our human brains, but we have learned how to mitigate so these issues by, for example, peer reviewing articles and books, curating databases, performing experiments, simulations, using tools like a calculator, right? So large numbers you can also not multiply in your head, but then you use a calculator. And this bit, the integration of structured knowledge, we call also a neuro-symbolic AI, where you have a semantic knowledge representation. And that's a bit the vision we follow, like putting a knowledge graph in between the neural models and the human, so that you can actually scrutinize and validate the information in the knowledge graph, which you cannot in a neural network. And that allows to incorporate a human and machine intelligence and have something like a substrate or a crystallization point for these two types of intelligence. What are knowledge graphs? So here's an excerpt on the right-hand side, an example of DBpedia. So in knowledge graphs, we have entities and relationships between these entities. Like here in this example, you see Bob Dylan and then a number of attributes like gender, birthday, family name, given name, and so on. And then you have also a relationship between two entities, like Steve Jobs is a fan of Bob Dylan and both live in the United States and so on. So this is very easy to understand for us humans. It's human readable, but also machine readable. Actually, AI and algorithms and machine intelligence can make sense also of these knowledge graphs. And on the left-hand side, you see the linked open data cloud. So every bubble you see there is not an entity, but it's a knowledge graph in itself. So you have, meanwhile, thousands of knowledge graphs publicly available on the web, and even more in private companies, for example, but also yeah, in supply chains they are used. So meanwhile, there are a large number of these kind of knowledge graphs. So how are the knowledge graphs different maybe from other formalisms? So they use a fabric of concept, class, property, relationship, entity descriptions, also some formal knowledge representation formalism, and there are these W3C standards, RDF schema, Auer, and many more which can be used. It's a holistic a type of knowledge where we have multiple domains, multiple sources, different levels of granularity, like, for example, instance data, which can be open, like DBpedia or Wikidata, private within a supply chain, or even also closed data, like product models. But you also can have derived aggregated data, schema data, metadata, taxonomies, links to other data sources, and mappings. And this all can be represented in this single knowledge graph, knowledge organization scheme. And that makes it also very usable for AI, because we have this integrated representation of the ground truth data, the metadata, the vocabularies, and many other forms. And meanwhile, there are a lot of companies. So this is actually a slide which is already 6 years old, which was compiled by Frank van Harmelen. So these were the companies which were building knowledge graphs at that time. And now there are, I guess, every company is basically building also knowledge graph to integrate their information systems and databases. Now, what about the language models? I think there are a lot of complementary properties. Yeah, language models are good at text processing, but they have no understanding of facts. Yeah, they sometimes and often get factual information right when it appeared sufficiently often in the training data, but it's a black box. There might be hidden biases. Also, sometimes a little superficial and computationally a bit more expensive, but this is maybe becoming less and less a problem. Knowledge graphs, on the other hand, are very good at representing knowledge. It's human machine readable, can be scrutinized, validated. It's very transparent. Yeah, we can look at the knowledge and the data, and they scale a little better. And that's why we have a number of opportunities to integrate them, where the knowledge graph represents a base of validated, trustworthy knowledge. We can integrate and organize enterprise or also research knowledge from various sources, and then use that also for domain-specific training, fine-tuning of the language models. And they, on the other hand, can become something like an interface, a front end for human interaction. They can help us create mappings, queries, or curate and recommend improvements of the knowledge graph. And I see this also a little bit here on the pathway to artificial general intelligence. So in the beginning, 2, 3 years ago, we had the language models used in isolation. Meanwhile, I think they all use retrieval augmented generation, like in the initial example where it is a web search, for example, ChatGPT, to find relevant information. This is meanwhile the standard. We also now go increasingly to knowledge augmented generation, where we provide access to more structured information sources such as databases, knowledge graphs. The next step is agentic generation, where they use also tools like reasoners, APIs, computational services, and basically trigger and operate these kind of tools. And somewhen maybe there will be AGI, where we have also then self-reflection, goal setting integrated. And that's a little bit the framework where we think and where we especially focus also on this agentic generation. Now coming to the research. So how does this affect our research and how can we leverage that? And if we look a little bit in other domains, here you see some examples. The information flows have completely disrupted and changed. Yeah, there are no mail order catalogs, no street maps, no phone books, no encyclopedias, and there were whole industries around these kind of type of information and business 20, 30 years ago, and completely disrupted meanwhile. Yeah. So what about scholarly communication? And there we still work with this traditional papers. There, not so much has changed in the last 4 centuries. We can now distribute the papers easier than 400 years ago, but the structure and the organization of the knowledge is pretty much the same. Although we now, of course, also add research data, but there is a little bit the danger that we end up with a data swamp instead of a nicely organized data lake. We also drown in this flood of publication. There are hundreds of millions of publication out there only in science and technology. 3 million are published every year. Large part is not cited, and reproducibility is a big issue. So there are many challenges there. Um, Also, the deficiency of peer review, for example, the quality, I think, is deteriorating, not because peer reviewers are not willing, but because it's simply too challenging, too difficult to deal with this flood of largely unstructured knowledge there. And we have a number of problems like a lack of transparency, a lot of information is hidden in text, a lack of integratability, machine assistance is a challenge. ID identifiability, we can identify the papers via DOIs, maybe the authors via ORCIDs, but if it's about algorithms, materials, concrete processes, there are no identifiers yet, and that makes collaboration very difficult, and we often look in the haystack, like illustrated here when you search for CRISPR on Google Scholar. And this is also a slide which is 6 years old. You found 250,000. I did that a few weeks ago. It was more than 1 million results. And if you are then interested in specific aspects of CRISPR, you're completely lost in this huge pile of knowledge. So now how can we fix it? And we actually aim to use this kind of knowledge graph approach to organize the concepts in research. And there also this domain-specific concepts, for example, substances, structures, reactions in chemistry, or experiments, data models in physics, and also the different artifacts like data, software, audio, the publications itself, and disambiguate these concepts inside such a knowledge graph. And that's what we do with Open Research Knowledge Graph. And here I maybe switch to showing you a live demo. So a feature which we just released last year is ORKG Ask, where you can ask any questions. And in all different domains, we have 77 million papers indexed here in a vector store. And for example, we can use this one here. What are the social implications of widespread adoption of autonomous vehicles? You get also here some warning. We have 77 million articles, but there are more than 200 million. But from these 200 million, we don't have more than just the titles. And in order to answer questions, we need at least the abstract. That's why we have only, of course, a bit limited coverage. Yeah. And we use such a RAG approach, retrieval augmented generation or knowledge augmented generation, to retrieve the most relevant publications here and then generate an answer. And that's what you see here on top, referring also then to the respective publications. And you can go to the publication and then you get also information directly extracted from these publications here in these columns of this tabular representation. In addition, on the left-hand side, you can filter, for example, by year, by language, or also by citation. So, for example, citation count, if you are interested only in publications which are cited more than 10 times, we can add this. And this actually comes from a knowledge graph, from a bibliographic knowledge graph. And then the answer also will differ because now we include only publications which were cited. And then you see that the language model runs. We don't use ChatGPT, but we use an open source model, Mistral, which runs on our own GPU cluster at TIB. So we are not bound to commercial services, but have some sovereignty here in that regard. Yeah, and here you can see that the answer became much more comprehensive. Yeah, and the number of the citations changed. And you can also change the columns here. So you can actually also launch a custom extraction, because what we extract by default here is relatively generic. And for example, we could add type of social implications. I don't know if that makes sense, but I just add it here. And then I can also move this to the front so it's more visible. You see that another column appears. And then we see here in this column, basically extracted from the particular paper exactly this information I was asking for. So there might be a hypothetical bias. Automatic vehicles may challenge assumption in the legal structure, and so on. So these are social implications which are now extracted specifically to this particular research problem. And what I've shown you here is such a neuro-symbolic search and discovery engine. But of course, like we have the ambition to create even more structured representation. So what you can do is actually you can export it. You can also import it in the Open Research Knowledge Graph. And I want to show you some examples from the Open Research Knowledge Graph. So this is, for example, here an example in material science, or if you go to the ORKG. Here, maybe I increase the size a little bit so you can see that better. You can go into different fields, for example, engineering, and there should be also somewhere materials engineering or material science, for example. And then you have here not papers, but comparisons of the state of the art. So we can then choose one of these comparisons here. And then you basically have here different papers from the literature in the columns, and then in the rows, you basically have information extracted from these papers describing the contributions from these papers. So here in that case, it's an analysis of ALD films across varied process parameters and material properties. So ALD is atomic layer disposition and etching, which is relevant for chip manufacturing. This is something we work on together in a project funded by Intel and Merck, for example. And then we organized here the literature, which basically analyzed different processes, reactants, and different temperatures. So I guess you know these details better than I do. And on a bird's eye view, you get here an overview of the characteristics of these different processes. So you don't have to read all these papers. These are actually here, we have 167 contributions. So 167 papers, each paper 10, 20 pages. So it's a huge amount of paper, but here you can then filter. For example, also you could go by the reactant if you are only interested in processes which involve a certain reactant. You have here a nice faceted approach to filter, and you could for example, just select those which you are interested in, and then only those will be shown, and you can relatively quickly analyze the state of the art with regard to this particular research problem. And the Open Research Knowledge Graph, so if you click on one of these contributions, you will actually get a detailed view, and then you see here this representation, and that's really then in the knowledge graph. You can also actually click here on the view graph, and then it shows you the graph, and you can look at the graph here. So and you can expand the graph, but this is here like the representation, and you see here the different, for example, the material, and if we click on the material, we will get could get more information on the respective resources. So let's yeah, and like this is a structured representation basically of the information from this particular paper here, where we on top also have the metadata, but then here this a more structured representation. And the Open Research Knowledge Graph is, of course, you can also access the paper here, go to the publisher or visit the paper itself to read it. But the Open Research Knowledge Graph is also generic in a way that Um, it's not bound to a specific domain, yeah. And here, for example, there is another domain which is energy systems. So this is something we did in NFDI for energy, and there we have collected contributions about, or basically scenario descriptions for transforming our energy systems. And you can again see that in the columns we have the papers here. Here it's a bit less. I think we have 25 in that case. And the description, the properties to describe the contribution completely different. We have here the energy sources, we have scenarios. So the first publication assumes 100% CO2 reduction till 2050, the second one only 95. And you can also see that it's represented in a machine readable form. And that has the result that I can, for example, create then such kind of visualizations in an automated way. So here we have basically the different energy types of energy, and then the installed capacity in gigawatt required to master the transformation. Yeah, so this is what the Open Research Knowledge Graph is about. And now I come maybe quickly back to the end of my presentation. I can skip here most of these parts because that's what I've shown you in the live demo. And just want to mention in the end here that we are now focusing on developing an AI assistant for the whole research life cycle. So the current alpha version prototype looks like that, where you have like different stages of the research life cycle here on the left. And on the right-hand side, you have a dialogue system, and then you have like sources or agents or different kind of tools which can be used. And in each of the step, you create a certain asset, and it allows you to, for example, create ideas for new research, determine new research question, and that based on your, for example, ORCID ID. If you give your ORCID, then this agent here, the assistant, knows the background you have, what you have published in the past, and will suggest topics for research based on your prior publications, for example. Yeah, and then we want to support each of the steps, like the method development, the implementation, the result analysis, and the paper writing with specific agents which are tailored to support you in each of these specific steps. And then, of course, they also need to be tailored to the specific research domains, because in material science, you will have probably other agents than in life sciences or in humanities. And we developed this as an open system, so everybody can also plug in their agents and their specific prompts and their specific data sets to support this research lifecycle. Keep the human in the driver's seat, so it's not a fully automated approach, but you can validate and verify each step here, which the AI does in collaboration with you. And we also want to create a representation of the results, basically, which shows the full origin of where every aspect, every detail came from and how they were put together, so that you have something like an audit trail in the end that you can verify, validate, and you have more trustworthy research, more reproducible research, and trustworthiness. Yeah, and of course we are, I'm not alone here, but we have a large team at TIB working on this, also on the community management and group leaders, many PhD students, software engineers supporting this. And we are interested to work with you on specific use cases. If you have a research problem where you would like to extract or work already on extracting information from the literature, we could add this to the ORKG, to an observatory, or if you're interested to work with us on a use case for this AI assistant, that would also be something quite interesting for us. So with this, I want to end my talk and thank you very much for your attention.